out the derivative. Dy by dx is what? Limit h tends to 0 f of x plus h minus
f of
x
by
divided by
x
h,
minus.
right? Yeah, if you're using here minus, then you need to write minus h also here, right? So this is what this is called as first principle method. So everyone knows what is first principle method. Like suppose I need to do for like I say derivative of x raised to n. Derivative of x raised to n is what? N x raised to n minus 1, right? Little bit of 11th grade. Okay, I just want to explain with this one example, right? So how do we get this, right? How do we get n x raised to n power x raised to n power x raised to n minus 1, right? How do we get that, right? So what we will do here, we will, what is our function? Y is equals to x raised to n here, right? So, or f of x is equals to this x raised to n. So I'll find out here dy by dx by doing what? Okay, like this here, limit h tends to 0. Now f of it is what? X plus h raised to n here, right? You can see because x f of x may x is replaced by x plus h minus x raised to n divided by h. Correct. So I hope everyone knows this method, but I'm just revising. Yes, we learned it in 11th, right? So this is what right, okay, 11th grade method only. Just I want to just take one example, right? Okay, you can do rest all, like I think you understand everyone, right? Okay, this one here. Now here we need to do this. Okay, right? What should we do further? What is the further, right? Okay, how do we proceed with this further? We know binomial formula, we can use that also. Okay, right? Or otherwise you have like, okay, that standard form also, right? Okay, you can use that also, but let me use binomial, everyone knows, right? Okay, so let me use the binomial form. H tends to 0. Now here n, what do we write here? NC0 x raised to n and h tends to 0 plus nc1 x raised to n minus 1 and then h power 1 plus, like this it will continue, nc2 x raised to n minus 2, then h square and so on, right? You know, like last term and all, right? Minus x raised to n divided by what? H. Correct. Now you can see clearly here first term and the last term, guys, this is what getting cancelled, right? This is what getting cancelled here because this is one, this is also one.
Yes, sir.
Yeah, from remaining part we'll take h common, right? So what is left out here? nc1 is like n only, x raised to n minus 1 plus nc2. What is left out here? nc2 x power n minus 2 into h. And then further terms also will be having h only, right? I hope everyone understand that. So h here, limit h tends to 0. Now h can be cancelled here, right? I'll be cancelling h. Yes. Now after this, what we will be applying the limit, right? We will apply the limit. H is what? 0. So only this first term is left out, which is not having any h multiplier, right? X raised to n minus 1 plus this is 0, further this is 0, all other terms will become 0. So that's a final answer is what? X raised to n minus 1. So this is what, okay, proper, you know, derivative to find out for any function. But we need to differentiate, we need to use derivative in, you know, like applications of derivatives there. So we will not do every time differentiation this way and then using derivative, you know, right? Okay, in physics, in chemistry also we use, right, rate of reaction. In physics we use, right, a lot, right, speed and all, right? Okay, ds by dt, dv by dt, acceleration, right? So derivative uses there, like we are going to see that further, right? So for we should know derivative directly also. So that's why we have to remember this list, right? What it is, that x raised to n derivative is what? N x raised to n minus 1. What is derivative of x? 1. What is derivative of any constant? 0. What is derivative of e raised to x? E raised to x. How these things are derived? Right, this first principle method, right? Everyone knows, no? These all, tell me. I'm just quickly going to do that. Okay, don't worry. Now d upon dx of f of x, right? So just revise with me. Okay, these all part, right? This all, okay, everyone. A raised to x, what is the derivative? Jyoti, you remember or not?
No, sir, I don't.
Ln of x, what it is?
1 by
1 by x. Sine of x,
cos x
cos x, cos of x,
minus sin x.
minus sin x. Revise it, guys, with me, okay? Because revision is there. That's why I'm doing. I know most of you know this already, but just to
6
revise
minus
again. Yeah. Then cot x.
cos
Whenever,
6 by
whichever,
minus cos
yeah,
x.
trigonometric sign starting, trigonometric ratio starting with c will be having minus sign, right? So sec square x. Secant x, sec x,
Sec x tan x.
10x, right? This is what it is there. Then what we have, okay, cosec
Cosec
x
x minus
sign,
minus cosec x cot x.
yeah, cot x, right? So these all are done, okay, right? These all we have. Then we have, can we do for inverse trigonometric functions also?
Yes, sir.
One second. Let me write this. Okay, for inverse trigonometric functions, guys, okay, what do we have? Like, yeah, sine
Sin
inverse
inverse
x.
x.
What
So
it
you
is?
have 1 by root of 1 minus x.
1 minus x square. Cos of inverse x, again c.
Minus 1 by 1 by root of 1 minus x.
Yes. Then tan inverse of x.
1 by 1 plus x square.
Yes. Cot
Minus 1
minus
by
1
1
by.
plus x square.
Yeah, I can see like, okay, most of you are replying, okay. So fine, I'm not able to see, but it good, right? Keep on typing, keep on right, revising. When you type, when you say it with me, right, okay, you tend to remember this. That is what revision, okay. Now secant x inverse x, what it is? 1 by, Jyoti doesn't know this, x into x square minus 1, right? Then what is cosec inverse
minus 1
x?
by whatever
Just
secant.
minus, yeah. Right. I hope you know, right? Okay. By chance, if you are confused with anything, okay, right? I hope you know how do we get these all also, right? Okay. Do you know that or not? Should I show it to anyone? Should I show it to anyone, right? How do we get these derivatives like that? Right. I know this we can get by first principle method, but I'm saying without that, right? Okay. Without that, how do we do these or how do we find out these? Mod x, right? Acha, yeah, right. Okay. You are saying correct. Okay. For this, right? Okay. This is what mod, right? Correct. Yeah. Okay. So see, for sine inverse, I can show y is equals to sine inverse of x. So what I do here, I need to find out what is dy by dx, right? From here. So what I can write down, if I take sine of both sides, because both sides it is like angles are written. Okay. So sine of y will become x. Now differentiate both sides. So d upon dx of sine y and then d upon dx of x. So this side it is 1. And what is the derivative of sine y? Sine y derivative is what? Cos of y, but y is what? Like because of that dy by dx. Chain rule kind of, right? Okay, chain rule. I'm coming to that. Okay, what is chain rule? So dy by dx is equals to 1 by cos of y. But we should not leave the answer in terms of y because they are looking for dy by dx. So we should ideally give the answer in terms of x. So we know sine y is what this. So can I write down here 1 minus sine square of y root over means 1 by 1 minus x square. That's it. This is how we get it, right? Everyone understand this, right? Okay. So I just showed one. Okay. You can check others also, right? Okay. Proof of this, right? Okay, like this, you can remember. Okay, fine. Let me show further methods, right? Okay, there is a what multiplication rule? Multiplication rule is what? D upon dx of, yeah, product rule, right? Okay, yeah, sorry, product rule.
Y is equal.
Product rule, right? Okay.
Yeah,
D upon dx of
f of
u
x
into v, right? Okay, vu or uv, right? Whichever you want to write. Yeah, you want to remember as two functions, right? Different or uv rule.
any
It was, yeah, it was famous for us like uv rule. So u as it is dv by dx plus V as it is du by dx, right? That is what product rule. Now, similarly, quotient rule is there.
That's U by V.
Rule d upon dx of u by v.
So
right?
it's du by dv.
V square, first
No,
V
sorry.
square down.
Yeah, V square down,
V.
V into du by dx.
V into du.
dx.
Denominator first, guys. Remember, du by dx minus u
dv by dx.
dv by dx, like that, right? Everyone is understanding that. Very good, right? Okay, this is what it is. Or dash, also dash notation you can use, right? Okay, that's it. Now, chain rule. Let me say that also, right? Chain rule is what?
F of g of x is equal to.
Yes, right. Okay, like suppose we have function composite function form, right? Okay, like suppose I have there is a function inside the given function, right? Okay, suppose like sine of
log x.
Yeah, okay, sine of log x, let's say, right? This is what y equals to given this. So dy by dx is going to be what?
Cos
what
of
is
log
it going
x
to be?
into 1
Differentiate the given function, assuming that it is what? Like sine of x only, so it will become cos of log x, right? But differentiate again log x, right? So what it will become? Cos of log x
by x
into 1 by x, right? This 1 by x you should write in front because it looks like, okay, angle to it, okay, right? So this is what, okay, like this, okay, cos of log x, right? It should right, you should write here, okay, don't leave like this is also fine because you use the bracket for angle, right? That's it, right? Everyone is understanding that? Very simple. Chain rule method. Chain rule is what? Okay, what we are doing actually, like, no, right? Should I write that properly? That we are assuming this as t, right? And this is sine of t. So sine of t will be what? Cos t. But dt by dx, okay, we need to write further, right? We were supposed to get dy by dx. And now what we have, we take it as t is equals to log x, suppose. So we will get dy by dx ke liye, we need to just find out dt by dx, dy by dt first, then into dt by dx, right? So these two things we can find out and we put it, okay, we get the answer like this. Clear, everyone? So this is what chain rule. It can continue to more functions also like that form also, right? Now parametric form. Parametric form also everyone knows. Parametric form ka derivative. Like suppose you have y is equals to 2at and x is equals to at square, right? You know y square is equals to 4ax. This is what parabola, right? If you differentiate this, this is 2y. dy by dx is equals to 4a into 1. So dy by dx is coming what here? 2a by y. This is what we got the answer. You can put y also in terms of x, right? Further, right? No, everyone, right? This is what we will get. 2a by root of this means 2ax, right? So 2 cancel. We are getting a by x root over. This is what the final answer, dy by dx. Now, if this is what given to us, parametric form is given to us, how do we differentiate this? So we'll write dx by dt is equals to a into 2t. And right, we got dx by dt, right? Like that. And we have dy by dt, right? Which will be what? 2a. Now what I need to do, I was supposed to get dy by dx. So what I can do, I just divide it, dy by dt divided by dx by dt. Clear? Yes, exactly, Larry. Right. So what we'll get here? 2a divided by 2at, 2a cancel, 1 by t. And t is what? T is what? From here you can see it is what? Root over of x by a. So this will become a by x only root, right? Same answer, right? We are getting. So if you do this way, right? Okay, parametric form ko we need to do this way. And for this Cartesian equation already given, okay, like that. So we need to do this way, correct? So I hope this is it, okay, right? Okay, for derivative part, differentiation rules, right? You need to remember this. Let's understand applications, right? Applications of derivatives. Fine. I hope everyone understand this. In 15 minutes. Log method also. Okay, yeah, log method also, right? Okay, that is also. Acha, right. Okay, very good point. Suppose, guys, we have some like, okay, suppose there is a function given, which is what? F of x raised to g of x. Correct? Suppose this kind of form is given. Variable to the power variable is there. So we cannot differentiate it directly. So what we need to take? Log on both sides. I hope you meant this only. Lahari, right? Okay. Did you say the same thing? Right. We need to take the log. Take log of both sides. Log of both sides we need to take. So log of y is equals to, log of this will be what? Gx into log of f of x, right? Now integrate, now differentiate both sides. Function raised to function, exactly, Abhinraj, right? Okay. Function raised to function, we need to do this way, right? Differentiate now both sides. 1 by y dy by dx is equals to gx differentiation of this. You know further what to do, right, for this, and plus log of f of x differentiation of g of x, right? This is what y you need to multiply further to this whole thing, right? Okay, so finally y will be multiplied. Let's take one example like this. Okay, right? We have many examples on this. Okay, right? Let me take this. Okay, like y is equals to x raised to sine x, suppose I have, right? So I cannot differentiate it directly. What I need to do, I need to take log of or ln of both sides. So it will become log x raised to sine x. First log rule. Log is doing what? It is making our work easier by bringing it into product form from the exponent form, right? Okay, like this. Sine of x into log of x, right? So it is 1 by y, differentiate on both sides, dy by dx is equals to sine of x into 1 by x plus log x into cos of x. Are you getting me, everyone? Is it too fast? Tell me. Let me know, right? If I'm just, because in applications of derivatives, it will take time. So that's why I'm doing it fast, okay? Sine of x divided by x plus log of x into cos of x. That's it. Right. Now, what is y? Y is x raised to sine of x. And this bracket as it is, right? Sine of x by x plus log of x into cos of x, right, everyone? This is what our dy by dx. That's it. This is how we need to give the answer. Clear, guys? Yeah, perfect, right? Okay, that's what it is. So this is how I think differentiation part is completed, right? Let me know. Anything else? Anything else is pending? Anyone? Done? Okay. We'll see like, okay, applications of derivatives like, okay, now, and I'll give you questions, good questions. I think here though, there is no problem. Sir, a few questions, please. Okay, fine. Let's do the questions, right? Okay, we can practice some questions here also. Tell me, guys, right? Okay, we should do some questions, I think, right? Okay, so yes. Question is first question. Let's do few questions, no problem. I know next chapter is what? Okay, LPP. So we can save some part. Okay, if it is left also from today's topics, we'll complete it in next webinar, right? Which is there on 25th, right? Day after tomorrow, right? So we'll complete there. No need to worry. Now, guys, what is the differentiate secant? Secant of tan inverse of x. Tell me the answer, proper answer, guys. Okay, everyone. I have answers. So I have options, right? Okay. So should I write the options? Differentiate this. Y is equals to this is what given. They're asking what is dy by dx. Should I write the options? Okay. Do it fast. A, B, C, and D. X by 1 plus x square. Here it is x 1 plus x square root. Then here 1 by 1 plus x square. And this is what? X by 1 plus x square root. Okay, these all options are given. Right, which is correct? Tell me. Farhan got the answer. Very good. Abhinraj? Abhinraj, just cross check. Why mistake? Yeah, Mrithin, correct answer. Shashank, Vedant, correct answer. Devashish, correct answer. Abhinraj, just check. Don't do silly mistakes, right? Okay. Sanskriti, what is that? Which option are you saying? Did you type it wrong? I know you typed the answer, but I think like, tell me the options, guys. Okay, very good. Yeah, most of you are giving correct answer. Just check it fast, everyone. Let me write next question. Meanwhile, they're saying here, x is equals to a cos cube theta and y is equals to a sine cube theta. Then, what is the value of 1 plus dy by dx square root over? What is the value of this? Yes, guys, do it fast. What is the answer? Give me proper answer, guys. Okay. And let me not write the answers, right? Okay. Are you sure? Farhan, there is one option like that, but are you sure about that answer? Okay, Avinraj, why? See, Avinraj, what we'll do here, dy by dx is equals to, secant is what? What is secant derivative? Tan inverse of x into 1 plus, what are we getting? Okay, wait, yeah. Sorry, my bad. Okay, if you're continuing like this, it will be complicated, right? Okay, what we can do, can we change it? Yeah, like this triangle help. Okay, with this help, alpha, right? Okay, what it will become? X here and this one, so 1 plus x square, right? So secant will be what? For secant, it will be what?
1 plus
This by this, right? Yeah, 1 plus x square. So 1 plus x square, this derivative of this we need to find out, right? Correct or no?
Yes, sir.
So it will be what? 1 by 2 root 1 plus x square, right? But chain rule will give me what? 0 plus 2x. Tell me. Got it or not? You need to remember root of x ka derivative is what? Directly d upon dx of this is what? 1 by 2 root x, right? Directly you should remember like that. Clear, no? What is the mistake you did, right?
Sir, the only mistake that I did was I didn't find the derivative, sir.
Okay. Yeah, you need to find
I did
the
till only
derivative.
there.
Okay. Derivative, then chain rule, right? You need to consider this as root of x and then chain rule, right? 0 plus this, right? That's it. Okay, guys, what is the answer for this? Nobody is typing the answer correctly, I believe, right? So far. Sir, confident. Okay. Shashank, Farhan, Devashish. Okay. Then Devashish. Okay. Varun, what is that? Okay, let me write the options now. Okay. Why I'm saying like, okay, see, wait.
1 minute, sir.
Yeah. Okay. Yes, Mehak, exactly. That's what the perfect answer, right? Prithvi, I need perfect answer. Harini, I don't think. Are you sure? Guys, options are given. Okay, let me write the options. First option is tan square theta. Second option is what? Secant square theta. Third option is what? Secant theta. And that's what the answer you're saying, right? This is the D option. Which one is correct? I don't think like we bother to read next option, right? Yeah, I don't think we bother to read next option if we already found the answer. Imagine this is written as first option. You will not check at all, right? Okay. Mode of mode, right? Oh my God. Okay. Mode of mode. You will not check, right? Now everyone is saying D, right? Otherwise, everyone was saying secant theta, right?
So
Jyoti?
it's not mod, right? It's plus or minus.
It is mod hatate tab plus, right? Okay, no, it is mod actually, right? Mod means positive, right? It is always positive. It is not plus or minus, right? You're taking it the other
Oh,
way,
right,
right?
right, right. Root
Yeah,
of x square is x. Yeah.
we have already discussed it a lot, right? Okay, Jyoti, let's
Yes,
not
sir. We've
discuss
done
it
it. Yeah.
here.
Root of x square. Yeah.
Yeah, fine. So nobody was saying that it is mod. It is mod of secant theta. Should I do it? Okay, guys, complete it. I'm just writing next question also because I know you guys are like, that's what you need to be confident. They can confuse you in simple questions also. So
So,
guys,
but
be
then it's
careful.
already tan square theta. So then why is it tan raised to 4 theta then?
Where is tan raised to 4 theta?
Like while differentiating d.
Okay, one second. Let me write the question. If x is equals to t square and y is equals to t cube, then d2y upon dt, sorry, d2y upon dx square. d2y upon dx square is, give me the correct answer, okay? I don't want to give the options. There is no need, I think. Mod secant or just it is secant? No, it is mod secant, okay? Root hai na? Okay, wait. Let me just find out first what is dy by dx. Everyone got this? Dy by dx is what?
Minus tan theta.
Sorry?
So minus tan theta.
Aja, minus tan theta, right?
square
Yeah,
theta.
minus tan theta. Exactly. Right, Abhinraj. Now we will substitute here, right? This value.
Minus
So it
tan
will
square
become,
theta, right?
no,
Minus tan theta.
minus tan theta. Why square?
Because it's cube and then becomes square, right?
So what? Cancels also, no? Few things. Just check. Chain rule. Oh my God. Okay, Jyoti, come on. Why we are doing silly mistake? Dx by d theta is equals to a 3 cos square theta into
minus sin theta.
minus sin theta. Chain rule. Abhinraj was doing some mistake like that only before. Okay, like he was not differentiating only, but I think yeah, Abhinraj perfect. No, now right? Okay. Dy by d theta will be what? Jyoti, tell me, are you understanding? 3
Yes, sir,
sine
yes, sir.
square theta into cos theta, right? This is what the derivative, right? Now we will divide. So we will be left with minus tan theta only. That we will substitute here. So we will not get sec theta, we will get mod of sec theta because root is there. Root is always positive. That's what we say, right? Root is always going to give the positive value. So if you are giving this answer, means sec theta could be negative also, right? That is not correct. Whatever it is, it has to be positive. That's what we are saying. Is that clear?
Yes, sir.
Okay. Now, what is the answer for third one? Farhan is saying one answer. Vedant is saying some different answer. Farhan, could you check it? Because Vedant, Mehak are giving same answer. Harini, no, some mistake is there, I think. Shashank, your answer is matching with the options. So that is correct. Yes. So far, Vedant, Mehak, Shashank, they are getting correct answers. So can you show second question completely? Okay, one second. Okay, guys, just check. Okay, whose answer I didn't say that is correct. Okay, see here, Mrithin, this is what we got. Now I need to get what? Dy by dx. So what I'll do, I'll divide this word second equation, this word first equation. Can I divide? Dy by dx will be what? This value, this particular value divided by this. So what will you get? A 3 sine square theta into cos theta divided by, right? It is means like this, a into 3 cos square theta into what? Minus of sine theta, right? Tell me, Mrithin. Are you getting it? A cancel, 3 cancel. 1 cos is cancelling, 1 sine is cancelling. What is left? Sine theta minus tan theta or not? Mrithin, got it or no?
sir. Like I didn't get the second derivative. I got the first derivative.
Okay, this one, this is you're not understanding this.
So second
Oh,
derivative.
sorry, Mrithini, sorry,
okay.
my bad.
Sorry. I got my mistake. I took the second derivative instead of squaring the first derivative.
Okay, fine. Understood now, right? Okay, that's what we need to correct these all silly mistakes only, Mrithini, right? Okay, that's what we're. If any doubt is there like that, guys, quickly open your mic. Okay, right? You need to unmute yourself and then ask immediately, right? Okay. Don't have any confusion. Yes, answer is correct, Jyoti. Jyoti, Devashish, right? Yeah, perfect. My is right. I have done this question 100 times. Yes, yours is correct. Okay. Mine is correct, right? Okay. Okay. So dx by, guys, yeah, how do we do this? d2y upon dx square. So we will differentiate this, right? dy by dt, we will get what we will get? 2t, correct? Sorry, dx by dt. And then dy by dt. What do we get here?
3t square.
3t square. Now we will divide, right? I know we need to get d2y by dx square, but we will get dy by dx here, correct? By dividing second by 1, right? Second by 1. So what do we get? 3t square divided by 2t. Is that clear, everyone? Okay, this is what we got. Right? This would, okay. Sorry. Yeah, it's correct, right? 3t by 2. Perfect, right? Now what should we do? I need to get d2y by dx square. So what should I do first? Replace t. Replace t by this. I think this is what better, right? Okay, t, it will be 3 by 2. And then t will be what? Root of x. Is that clear, guys? So finally, what I'm saying, dy by dx is nothing but 3 by 2 root of x. Clear? Now differentiate once more because I need to get d2y by dx square. So d2y by dx square will be what? 3 by 2. And I told you this, you need to remember directly, 1 by 2 root of x. Correct, everyone? So 3 by 4 and root of x is what? T itself, right? Because they're giving answer in that term only, right? Okay, this is how they're giving. Options are given like this, 3 by 4t. That is what our answer, right? Everyone understand this? Mrithini, do you understand that? Or anything different answers there? Why is root of x? Mubashir, because we need to get, right? What is t from here? Root of x, no? Right? We can say like that or no? Tell me. Clear? That's what we're doing. Yes, yeah, okay. Got it, no, everyone? Yes, perfect. Mrithini is saying yes, got it. Right, guys, so practice. I know if we keep on doing, like, I know we need to practice a lot, but okay, we have limited time. Chalo, no problem. One more question. I think you guys are enjoying questions doing.
Okay.
Yeah. Feza, right? Feza. Hello. Any doubt is there? X is equals to A secant theta, comma, Y is equals to B tan theta. Now they're asking d2y divided by dx square. Okay. Okay, fine. This is what we need to find out. Yeah, Feza, your mic was on.
Sir,
Yeah, Harini, tell me. Yes.
could you explain the last two steps of the previous sum, sir?
This one. Okay, guys, do this question if you got this. Okay, Harini, yeah, tell me from where. Did you get dy by dx here or not?
Yes,
Do you
sir.
understand? That part you understand? Dy by dx is what? 3 by 2 root of x. How I replaced this one here? Because see, I need to take help of what? I have dy by dx here I need to make. So I should write in terms of x only so that I can figure, I can find out what is d2y upon dx square. So that's what I did here. I replaced t as root of x. Clear? Tell me. Not getting this.
Say dy by dx is equal to 3 by 2 root x.
Yes.
Then how root x becomes 2 root x, sir?
I just said above also. This is what? Okay. How it is becoming 1 by 2 root x? That's what you're asking.
Yes, sir.
X raised to n. What is the formula? Tell me, Harini. N x raised to n minus 1, right?
Yes, sir.
So what is the power here? N value is what? Half, right?
Yes, sir.
So half means 1 by 2. And then x power will be what? Half minus 1. So that's what? Minus half, right? And because of minus half, root here. Not getting.
Understood, sir.
Yeah, that's all. So remember it directly. I'm telling you again and again. Remember this directly. Root of x derivative is what? 1 by 2 root x. We are getting by this only, but it is what? Fractional power. So that's why it looks sometimes different, right? Okay. We don't realize okay that it is becoming like this, right? Got it now?
Yes,
Clear?
sir. Yes,
Yeah.
sir.
Remember this now. Okay. Now you should remember every one of like this. Okay, guys, answer here. Fourth question. No answer till now. Okay, should I give the options? I know. I think answer is coming little bit. Options, please. Okay.
So
First.
I gave one answer.
Yes. Yes, that is there in the options. Wait. Okay. Yeah. 1 second. 1 second. Okay. Okay. Yeah, guys. Okay. 1 second. Right. Let me write down options. Devashi is just check. Okay. I think Vedant's answer is exactly matching there. Okay. This is what first option. B option is minus 2 root 3. B divided by A. C option. I don't know what is the correct answer. I need to do this. This is what it is. These are the options. Yeah, I think everyone is getting correct. Okay, Mehak, Shashank, Farhan. Yes, Devashi is correct. Rithini, which option? Caught. Caught. Caught may answer you are giving. Prithvi, yeah, correct. Vedant, you also said the correct answer, I believe. Yeah, that's the answer, right? Okay. Cube.
No, so
Vedant?
square. I typed
Yeah.
mistake. Yeah.
Okay. Mrithini, did you get it? Varun, no. I don't think that is correct. Because majority is saying something else. Should I do it? Okay. Varun, correct it yourself, otherwise I'll do it. Okay. One more question. Yes, Aryan. Nishita, no. Nithini, that's correct. Nishita, no. That is not the answer. Jyoti, correct. No, it is not. No, Varun, it is not that, right? Okay, wait, I'll show it. Okay, 1 second. Let me write down the next question. Question number 5, guys. Here I'm writing. If x plus y is equals to t minus 1 by t and x square plus y square is equals to t square plus 1 by t square. X square plus y square is equals to t square plus 1 square. What is the value of dy by dx? If you want, I'll write the options, okay, in some time, but try it first yourself. You should get the answer in terms of x only, right? Options are given in terms of x only, right? Derivative should be in terms of x only for fifth question, right? Let me do this. Oh my God, I just wrote it here. Let me place it down. One second, guys. Yes, Varun. Why are you not getting the answer? Okay. Constant? What do you mean by that? T is a constant. Where? Which question? Not constant. Acha, last question. In the last question, I think this is. Yeah, right. Okay, correct. Yeah, we need to consider it as constant only, like parameter, like A, right? A or B, correct. Yeah, I should have written here A or B, right? That would have been better, right? Correct. Yeah, you need to consider it as A or B, like, okay, like that, constant. Constant means to फिर तो zero हो जाएगा. No, wait. There is nothing mentioned in the question, right? Okay, that is also weird.
So first we need to differentiate it completely, then only we can apply theta. No?
No, if it is constant, so from first equation only we can get the, no guys, it is variable only. You can say T is a parameter, okay? Parameter, or you can say like parametric form, it is like that, okay, given like that, parametric form. You cannot take it constant, because otherwise, so you differentiate first equation only, you're getting dy by dx, right? So that's not correct. Okay, T is a parameter. Though it is not mentioned in the question, I know it should be mentioned. Okay, fine. Dx by, let me do this question. Okay, you guys just do that if you are done with this fourth question. Dx by theta will be what? A secant theta tan theta, right? Tell me, Varun, this is what you did. Now dy by d theta is what? B secant square theta, right? That's what it is. I'll divide this by this. So dy by dx I'm getting as b divided by a secant theta by tan theta. What do you say? Right? That's what we got. Sec by tan. Right. Okay. Now what should I do? I'm going to write. Okay. Differentiate it with respect to. We can differentiate that as a constant too, right? Which question, Abhinraj? Fifth question. Okay, yeah, fine. Okay, one second. Abhinraj, I'll check that. Okay, fine. Yeah, okay. What you are saying, that is correct. Okay. Sine by sine cos may also you can make dy by dx is equals to b divided by a. Okay, Varun, you want me to change it to sine and cos? No problem, right? What it will be? It will be just cosec, right? Cosec theta. Tell me. Because 1 by cos, sine by cos, so cosec theta. Clear or not? Yes. Now, I need to find out double derivative. So, differentiate both sides with respect to x. So, d2y by dx square is equals to b divided by a minus of cosec theta, right? Minus of cosec theta and d theta by dx. Are you understanding this? What did I do? I have differentiated both sides with respect to x, right? So I need to write this or not? Tell me. Right? That is what extra will come. Exactly. Right? Now this dx by theta value I have. Actually, d theta by dx here. Yeah.
So minus cosec theta cot theta, right?
Oh, sorry. Cot theta. Exactly. I missed that. Minus cosec theta, cot theta. Right? And this. So we need to divide by this expression because it is what d theta by this here. So finally what we'll get? Cosec theta, cot theta divided by what? A, and b by a was there. B by a secant theta, tan theta. Now that's it, right? Okay, because why I converted it into theta form? Because I need to substitute this. Now put that value, right? So minus b square, b by a square and cosec of pi by 6. I think we can cancel something or what? It is cot or tan. Yeah, it's fine. Okay, right. Tan I can write down secant of pi by 6. You need to just put the values, right? Okay, tan pi by 6 whole square, right? That's it. So minus b by a square. I just cancel quad from there, and that's what I change it to this square, right? Okay, like that. It is fine, whichever way you do. Okay, that is what answer here. 2, right? We'll get 2 no here. And then here, secant is what? 2 by root 3. And tan is what? 1 by root 3 whole square. So 2 gets cancelled. We are getting 3 minus 3b divided by 3 by root 3 a square. Then we need to rationalize. So we get finally 3 root 3 b divided by 3 a square. Oh, this is getting cancelled, right? Wait, did I miss something? Okay. What is the answer you guys got? Okay, 3. This is 3 here. So 1, 3 will be there. Then this 3. Root 3. 1 by root 3. Cot theta, right? Okay, whichever value, right? Okay, like you can change it to that, right? Okay, no problem. What it is, minus b by a square actually. This is what 1, okay, let's change here only sine by cos, because substitution will be easy if you want, okay, right? Like that. B by a, so it is what? 1 by sine theta, then cos theta by sine theta, right? If you want to change it to this, right? Okay, like this, 1 by cos theta and sine by cos theta. Minus b by a square. Okay, it was better than before. Sine square theta, cos theta. Then here, cos square theta by sine theta. Okay, fine. That is what you were saying, right, Prithvi? Right, it is becoming cos cube theta by sine cube theta, right? And this word minus b by a cot cube theta, right? That's what it is. Perfect, right? It is a square. So guys, just substitution. Be careful about that part. That's what I think I missed some term there. But it is what? Cot of cube theta we are getting. So minus b by a cot pi by 3 is what? Pi by 6, sorry. Pi by 6 is what? Root 3 whole cube, which is what? 3 minus 3 root 3 b divided by a square. So you can do this way also, right? Okay. By the way, here also same answer you should get. No need to worry, right? Just check that, right? That's
sir. I think you just made a mistake in the second last step, sir. In the
Here?
first, yes, sir.
Yeah. Here, right?
1 by 3 root 3, sir. There you go.
Yeah, right. Okay, I left. Okay.
After that, you just wrote 3 by root 3, sir. It should have been.
This was also fine.
3 root 3.
Perfect. Yeah, I know, right? Okay, so both ways it is fine, right? Okay, guys. That's what you need to substitute. It is becoming minus 3 root 3 b divided by a square, right? That's what the answer here also. Correct. Same. You can continue in any method, right? Okay, here. Yes. Who all got it? Okay, this one here. Basically, see, okay. Nice. Very good. Mirthini, correct answer. Wait, sorry, Varun, what is the answer you got? I'm sure that not right answer. Okay. Mirthini is giving correct answer. Wait, Avinraj, no, I don't think that is, yeah.
Exactly. That's why I
Yeah.
said.
Larry, no. Okay, fine. What about others? Okay, in terms of x only, answer should be there, right? That's what we want. Okay, see, everyone remembers it is what very easy to convert these two equations to bring into one, right? Okay, like that. And t is what? Very good, Varun. Yeah, I think yeah, that is what correct answer. Very good, Varun. Yeah. So what we do, first equation, and if I do the first equation, square both sides, right? X plus y whole square is equals to t minus 1 by t whole square. What do I get? X square plus y square plus 2xy, right? 2xy is equals to t square plus 1 by t square and minus 2. Do you get it? Right? Okay, everyone tell me. Now, what is given to me? This is given, right? This value is what? X square plus y square. I'm substituting this from second. Minus 2. So what I'm getting here finally, x square plus y square plus 2xy. These two terms are getting cancelled. So xy is equals to minus 1 and y is equals to minus 1 by x. So dy by dx is what, guys? 1 by x square. Any doubt, anyone? Any doubt here? Abhinraj, tell me, like, did you do this? We need to first simplify this parameter only. It is not constant. We cannot consider this
Yes,
as
sir. I
constant.
just tried it with the constant, like if considered.
Okay. Yeah, no, no,
A
no.
damn wrong answer, sir.
Sir,
Yeah.
it's minus 2t, right?
Minus
2t.
whole square, Harini. How it is minus 2t? Product of the terms, right? This 2 at, right?
Okay.
This into this, right? T into 1 by t. So this gets cancelled, no? Got it now?
Yes, sir.
Yeah. Okay, everyone understand this, right? So questions could be like this, right? I think these are like thode hatke questions, right? I hope you know this also, right? Let me take this type of question also, because you should know this also. By chance someone have not practiced this kind of question. So let me take one more this question. E raised to x cube, they are saying differentiate e raised to x cube with respect to log of x. What will be the answer, guys? I hope you know, right? Question, this type of questions. They can ask differentiate sin x with respect to cos x. Do you understand the question? Or anyone has doubt in that? We need to do applications also, guys, first. Yes, Prithvi, perfect. Right, that is the answer. Karan, correct. What about others? Aryan, what should be the answer? Devashish, correct. Yes, very good. Abhinraj, what should be the answer? Harini. Okay, one more nice question. Derivative of sine inverse this with respect to sine inverse x. X is less than 1 by root 2. Yes, Lara, perfect. Mithini, some silly mistake. Answer will be in the form of these only, right? E raised to an x, right? Like that, in terms of x only. Yeah, exactly, Latika. That becomes x cube, right? Okay, that's it there. X square into x 0, x cube it will become. Yes, Larry, your answer is perfect. Okay, so what we do in this type of question, okay, let's say this is y and this is what? Something like z, let's say, right? So basically what they want, dy by dz. Whenever they say with respect to x, when we say, we write down dx. With respect to this, they are asking, so we'll assume this as some variable z, right? That is what we are going to do. So what we'll do here, first find out, this is what I need to get. So what I can get, dy by dx, we'll find out first. Dy by dx will be what? E raised to x cubed, then 3x squared, right? Everyone is understanding chain rule, right? Dy by dx. Dz by dx, I can find out what it will be, 1 by x. Simple, right? Now divide, that's it. Dy by dz I need to get. So dy by dx divided by dz by dx. And that's it. We are getting e raised to x cubed into 3x squared divided by 1 by x, which is coming. This is what our answer, final answer, right? Very good, Mac. That is the answer. Abhinraj, no, seventh answer is not correct. You did some silly mistake, okay? Answer, close answer, but you're getting something extra. Prithvi, perfect. That is the answer. Prithvi and Mac got it. Okay, I think we need to start applications of derivatives now. Yes, yeah. With respect to that, right? Okay, so you'll get it now, right? I think, yeah. Okay. By the way, answer is what? Should I tell the answer to everyone for this question? Let's do applications of derivatives now. 1 minute. Okay. Yes, Lahari, that is the answer. Perfect. Sorry, what's your name? CEYA, is it? Yeah, that is the correct answer, by the way. CEA, right? I don't know. I don't know if I'm pronouncing it correctly. Sia, okay, Sia, right, okay. Fine. Yes, Abhinraj, perfect. Right. Answer is what here? Answer is 2, right, for this question, right? So do it, okay, later on. Methane, no, 2 it should be, not -2, 2, right? Very good, Abhinraj, you got it right. Okay. Everyone else also do. Should we do applications of derivatives? One more question I'm giving you. I hope everyone knows what we do for this. Root of x plus root of x plus root of x. I hope you know, right? Okay, what is the method? Infinite times, right? So we take from where the repetition is starting, that will be what? It will convert to what? Everyone know this, right? This is what it is. Now differentiate in both sides, right? Okay, we'll get the answer by whole square and 1. Yes, Aryan, that is the answer. Yes, exactly. Very good. Fine, guys. Okay. Yeah, I'm done with the questions which I have. Okay, here, right? Okay. Let's do further, right? Okay, applications of derivatives. Okay, let me know, right? Okay, what all is there? Maximum, minima, tangent, increasing, decreasing, right? I think that's it there, or something else is also there in the portion. What do we have in the applications of derivatives?
So
Dari, which question?
tangent normal.
This. Yeah.
That's it.
Okay. So yeah, increasing, decreasing is there, Jyoti, right?
Increasing, decreasing, minimum, maximum.
Tangent normal. That's it, right? Not approximation and what? Anything else? Right. Okay, that's it, right? Even that mean value theorem and all, that is also cut off or what?
No, sir, that's also there.
That
It's
is
not
there?
asked very often, but
I don't know, like, okay, if it is there. Rules.
No, mean value is not there, right?
Not there, right? Yeah, it is removed. Jyoti.
no, I think Rawls theorem is there.
No, that
No,
is also.
both of them are not there.
Yeah, not there. Yes. Okay. So we have tangent normal, maximum, minimum. Let me do that part, right? Okay. So let's start, guys. Applications of derivatives, right? AOD. Okay. What it is first? increasing, decreasing. Should I do that only, right? Increasing, decreasing, we will do, right? Okay, whether a function is increasing or decreasing, right? We need to check that. Increasing, decreasing first. Right, okay. So what we do here, right? Okay, there are two methods, right? You can differentiate and then check. Okay, that is what obviously derivative. Yes, yeah. There are, but this is also there, right? Okay, that if there is a function f of x, x1, let's say less than, right? Okay, if f of x1 is less than for f of x2, right? Okay, like this. So from with respect to this, okay, f of x1 is less than f of x2. For what? Given that what x1 is less than x2. So then what? It will be increasing or decreasing, guys. This is the case. Okay, see here, like this it is there. At this point, at the first point, okay, here x1, this is what x2. So f of x1, this is what f of x1, right? Everyone is understanding y is equals to f of x, right? F of x1 is this. Now f of x2 is what? This one. So when this condition less than and here also less than for x1, x2, so then it is what? Increasing, right? Everyone understand this? But if it is reversed, if it is, yeah, it is, so we'll say f of x is what? Is increasing, right? Okay, increasing it is. But if it is something like opposite, okay, by the way, okay, one more thing should I write down? Okay, f of x1, okay, f of x1 is greater than f of x2. This implies x1 is greater than x2. Now what it is now? F of x1 is greater than f of x2 and x1 is greater than x2. What it is right now? Is it decreasing right now? Is it decreasing? Still increasing, right? Don't get confused. It is still increasing. So that's why I would say, now what is changed actually? X2 is here, x1 is here. So many people are like confused. Okay, is it like that? Just you need to be careful about this part, right? Okay, like that. This is what's seen here. And position should not change. Otherwise, if you write it here and there, okay, right, it will be reversing inequality. So that's how it is, right? It is still increasing, right? But if it is x1 less than f of x2, implies x1, x2, this is what it should be less than increasing, but it is opposite, suppose, right? If it is opposite, then it is what? F of x is decreasing, right? It is decreasing. Clear, everyone? If it is opposite, right, this sign is what? Opposite, then it is what? Decreasing. You can see clearly, right? Okay, that in the graph you see here, when it is decreasing, this is what? X1, this is what? X2. So, okay, sorry. F of x1 is less than x2. I'm saying this one. So this is what? X1 and this is what? X2. Right? Okay, like this it is. Opposite, because x1 is greater than x2. So this side we need to keep it. So it is what? Decreasing case. Till here everyone understand? And remember, we are always seeing from left to right. Okay, not opposite. It is increasing this side. If we go this side, it is increasing. But we always observe when we are saying increasing or decreasing, we will say from left to right only. We will observe from lower value of x to higher values of x. Like that it is. This side are what? Lower values to higher values. Minus infinity to positive infinity, right? That's what you need to be careful. Otherwise, so it is increasing this side. Someone will say, sir, it is increasing for me. I'm doing just this side like that, right? So that is increasing, but we will, when we say in general, it is increasing from lower values to high values of x, like that we are going to see, right? Okay. So that is what the method. Otherwise, what is there? What is the other method we have? Like we will differentiate it. We will see there, right? Okay, what it is, what is happening there at the derivative is being positive or negative, right? So let me explain that derivative part also, and after that I'm going to see give you questions, and you need to do it properly. What all we learned already, derivative part will be used here, right? So you need to be careful about that part also, right? Okay, derivative also you need to do properly. Yeah, guys. Okay. Any doubt in this part? First of all, this is what, like we can simply check this way also. So I hope everyone got it. Okay. Increasing in some interval, it could be there, and then decreasing in some interval, right? Okay, decreasing on some interval, strictly increasing. What is strictly increasing? When it is always greater, right? Always greater or lesser. If it is equal to return, equal to means it is increasing but not strictly increasing. Are you getting me, everyone? Means they have become equal also for some time. I hope you understand it from the graph also, guys. Like this, it is there. Then it became still, right? Okay, like that. It didn't decrease, but it is what? Same for some time, right? And then it started increasing, right? Like that. This is what called as increasing. But is it strictly increasing? No. This is not strictly increasing, right? It became constant, no, for some time. So that's what, in this case, what we'll say, if we find out derivative, it'll come greater than or equal to 0. If it is greater than 0 all the time, then it is what? Strictly increasing. Make sense or not to everyone? Just like a car in traffic. Yes. Red to green. Okay. Yeah, exactly. Very good. Yeah, guys. Okay. Very nice example. Huh? Abhin Raj. Okay. Okay, fine. So let's see the questions, because I think everyone understand, right? Okay. What about this function? Okay. If there is a function which is given like that, whose graph is just like that, is it increasing, decreasing, or what? Neither increasing nor decreasing. It is a constant function, right? Okay. Sometimes it is like this, y is equals to f of x is given like that graph. Neither decreasing nor increasing. Okay, remember that also. So guys, okay, now let's do the question. F of x is equals to x cubed minus 3x square plus 3x. This function, just tell me about it. Is it strictly increasing or increasing, or decreasing, strictly decreasing? 4 options are there like that. Is it strictly increasing, decreasing, or strictly decreasing, right? Okay, like that. What should be the correct answer? And in what interval it is increasing, if you are getting different intervals? Do it fast, everyone. Question number 1 here, because I know theory part, to most of you understand. Main thing is what? Okay, on questions, how do we apply that theory? That is what we need to revise. And we need to avoid silly mistakes, right? Okay, we should not do those. Should I write the next question also? Faster, guys, faster. Okay, everyone is able to see it clearly, or should I zoom in more, right? Okay, because I think last class few of you were saying, should I zoom in more, or is it clear? I'm keeping it like this, okay, because I want to do more questions, but it is not like, okay, if you have difficulty, I'll change the font. Means I'll write it bigger. It is 17 at the end. Mithini, first answer. That is the answer for the first one. Are you sure? Mithini, Aryan. Very good, Larry. Perfect. But what interval, Larry? In what interval you are saying that? In what interval, Prithvi? What is the interval for that? Exactly. Very good. Perfect answer, Larry. Do next question. Question number 2. Very good. Prithvi, what is the interval? Mehak. Mehak, are you sure? Yeah, Prithvi, do next question. Good. Abhinraj. Which question? First one? Guys, why are we doing mistakes in simple questions? Seriously, Abhinraj. Mehak, I think some silly mistake is done or what? Should I do it? We'll find out f dash of x, right? F dash of x will be what? 3x squared minus 6x plus 3. Can I take 3 common? 3 is common. What it is like, okay, x squared minus 2x plus 1. And now what we are getting? I just said, okay, is it increasing, strictly increasing? Acha, okay, that way you're saying, Mehak, right? I think you found this only, this is what it is. Now this value is always greater than 0. No, it is equal to also. So function is increasing for all r. Increasing, not strictly, increasing. What we will say? Increasing for r. That is what, right? Okay. I know, okay. So you wrote, okay, wait, Mehak, you wrote strictly increasing. Okay. Wait, but yeah, 2 to infinity. I forgot differentiation of 3x. Yeah, Mag, we need to be careful, right? Okay, these mistakes, right? Mrithini is also saying silly mistake. Right, be careful, okay. City one here. Abhinraj also. Okay, guys, that's what, right? Note down, if you want, just make a short note that I'll not do this mistake again, right? Okay, in the exams, note down like that so that you'll remember that mistake, right? If you want, note down that it is very, very important to save 1 or 2 marks. Otherwise, we come home and we realize, oh my God, I did silly mistake here. I knew this perfectly, right? Okay, like that we realize. So I'm telling you that before only, right? And we feel, okay, no, next time I'm not going to do that. Okay, so you can say that right now only to yourself, right? Okay, next time I'm not going to repeat this, right? Like that. But don't keep this thing too much in mind. Okay, sometimes it it creates other doubts. Okay, right? But just do it relaxedly, but be careful. That's what called as presence of mind. When we are thinking something else, okay, like what I do actually, I keep on, like when I'm doing this step, I start processing for next step. That's what the problem, okay, I get. So you should not do that, okay, right? Just go step by step. That's why. Sometimes when you do fast, okay, I'm doing fast because I want to do more questions. So for me, it is fine, but you should not do that, right? Okay, you should first do that question, right? Okay, like in cricket and all they say, no, we want to just win this match, right? And we lose to Pakistan. We give big statements, right? Okay. Oh my God. That, okay. No, we want to take it as a match. Okay, like this is just a match. Okay, we are not thinking about future or past. Okay, we're just taking it as a match. Okay, I lost it. Okay, chalo. Fine. Oh my God. Okay. So f dash of x is coming what here? 6x squared minus 30x plus 36, right? Now 6 common, take common, right? Okay, common, if you take, okay, you make things simpler for yourself, right? 6 5s are, right? And then 6 6 are, right? That is what it is. We can factorize it, right? X minus 2 and x minus 3, right? We should be good in that part, okay, right? Okay, like this here, Vedic method, we should know 2, 3, right? And that's what it is, right? 2 times it will intersect, positive, negative. So increasing in what interval? Minus infinity to 2, 3 to infinity, increasing, decreasing in 2 to 3. Got it, everyone? Can we move on? Yeah, everyone understand, I believe, right? Okay, that part. I sent it 8 times, sorry. Okay, I was busy in... Okay, fine. Sorry, Clary, I didn't see that. Good, okay. Okay, let's do next question. I'll see this time, okay, Larry. I sent it 8 times. Oh my God. Third question, I think, right? Okay, what it is? F of x is equals to sine of 3x minus cos of 3x, right? Sine of 3x minus cos of 3x. What they're telling, okay, x lies in the 0 to pi interval. So you need to check whether, sorry, you need to find out the intervals in which it is strictly increasing and strictly decreasing. Find intervals for strictly increasing and strictly decreasing. First part, second part. Oh my God, I didn't read that. Okay. Abhinraj is saying, I will understand most of the mistakes when I am in the toilet. Almost all time. Okay, nice. टॉयलेट में बहुत आइडियाज आते हैं. I know, right? Okay, that is common. Okay, Abhinraj.
Sir, there's even a name for that. It's called shower thoughts.
Yeah, like we feel like relaxed. No, that's why, like, okay, we realize, okay. Okay, nice. Chalo, next question. Okay, this question, guys. Toilet Thinkers Private Limited. Okay, Arpan is there. Nice. Toilet Thinkers Private Limited. Is it there, something like that? Oh my God, seriously? Nahi hai to bana do. It is good. Toilet Thinkers Private Limited. Website. Take the copyrights. Okay. Now only. It is really good. Oh my God. Someone must be having this name also. This website like that. Okay. Or something like that. Registered, something like that. Okay. Fourth. Let's do it, guys, fast. Okay. We need to revise as much as possible. Okay. So that for next lecture, we should keep minimum pending. F of x is equals to minus x by 2 plus sine of x. Okay. And x belongs to minus pi by 3 to pi by 3. We need to check in this interval, is it increasing, decreasing, constant, none of these. Those are the options given. Okay, guys, what is the answer for above one? Third question. It looks like everyone is thinking now, not doing question. We need to do tangent, normal, maximum, minimum. Oh my God. Sir, I'm stuck. Why? What is the problem? Here, okay, what do we get? F dash of x is equals to 3 times of, right? I'm writing 3 before only because cos 3x into 3 we will get. So 3 cos 3x. Minus here, minus plus, it will change because it is cos, right? Okay, and we'll get 3 sine of 3x. Tell me, guys, everyone is getting that 3 common? Cos of 3x plus sine 3x. I hope everyone knows what do we do for this. Does everyone know what we do for this part, right? How do we do this, right? How do we decide for this? Actually, yeah, here though we need to make it equal to 0, right? Okay, so you don't need to combine, right? Okay, so let's just make it equal, right? That's it. I don't know how to go ahead from here. Okay. Equal to 0, right? Varun, we'll do equal to 0. What we will get? We will get, I think, what? Okay, tan of 3x is equals to minus 1, right? That's it. Right, exactly. Mehak, 3x it is, right? It was 3x, right? I hope you took that properly. Oh, that was silly. How? What? Equal to 0 karenge, right? It will go this side. So tan of 3x, right? Like that. Yes, right, to 3x. Okay, good. Sir, not cot 3x. You can take cot also, but I think tan is what better. Tell me. If you do reciprocal, right? Okay, we'll get that also, right? Cot also will do. But I think tan is better. Because tan graph we understand better, right? Okay, like that. Now what they're telling, okay, this is what 3x is equal to this, right? Okay, so we should understand, right? Okay, now general equation, right? Solution. I hope everyone knows that 3x is equals to what? N pi plus minus of pi by 4, right? Minus of pi means it will become n pi minus pi by 4, right? 3x. Now 3 say we will divide both sides, 3 here and 12 here, right? Like that's we are getting. That's what I'm saying, right? 3x we get, no, like this interval. No? Mahak? Yeah, guys, tell me everyone. This is what we got. So n value, right? Okay, what we want to keep, okay, in this interval. X values are what? In this interval. You can take the help of Rakshita is there, okay. Windows sound came like old Windows. Sir, I got 0 at pi by 4. Wait, okay, the interval is what? 0 to pi, right? But this, because of this 3x, 10x is showing what? Okay, periods like its period is changing to what? Pi by 10x period is what? Pi, right? It is what? Like this up to pi by 2. But now because period is changed, okay, it is what? Pi by 3. So it will be what here? Pi by 6. Tell me, pi by 6 till here, pi by 6. Then, and here minus pi by 6. Are you getting me, everyone? Pi by 6 it will become or not? Pi by 3 is the period because it is 3x. Okay, I'm taking help of graph. Otherwise, you take the general value also, right? It is your choice. Correct. So 0 to pi by 6, it is becoming positive or not? 0 to pi by 6. Right? Okay. Are you getting me, guys? Okay, 0 to I can just do it from here that this is what becoming positive here, like this 0 to wait a minute. No, this point will come. So can you please solve with the help? Okay, let me show it. Okay, without that this only. I know. So it will become confusing. Listen here. Now, what is the like n equals to 0 if we put? What is the value we are getting? N equals to 0. It is what? Negative. That is out of the interval. So we'll not take n equals to 0. N equals to 1. N equals to 1 gives us what? Pi by 3 minus pi by 12. So we will multiply here 4 and we are getting 3 pi by acha, right? That's why Mahak, okay, right? It is becoming pi by 4. Correct? So 0 to pi by 4. 0 to pi by 4. It will be what? Okay, see, we got the critical point like that, but this is becoming what? Positive or negative in this interval? Tell me. 0 to pi by 4. It will be what? Positive or negative here? We want to see where it is positive, where it is negative, right? So that's why we equated to 0. Critical points are coming pi by 4. Then I think, okay, n equals to 2. If I put, right, n equals to 2, we are getting any other critical point. That is where it is becoming 0. So we are kind of getting like 0, then pi by 4. And some other point is there. If you put 2 here, what are we getting? 2. If you put 2 here. Yeah, n equals to 2, right? Okay, I'm saying 2 pi by 3, which is what? 120 minus 2 pi, right? Yeah, we will get that also. That point also will come. 2 pi by 3 minus pi by 12, right? I think answer, okay, right? I think you will get the answer here. What are the values we are getting for this? Yes, one interval will be 0 to, it is increasing for, okay, question, did I ask the question, in the question what was there? One thing was, one second guys, 3x pages. Yes, it is what for this interval 0 to pi by 4. That is what we are getting. 0 to pi by 4, it will be positive. Then Here, second point will come from here. What we are getting here, guys? Okay, 2 pi by 3, 4 here, 4 here. So what we get 6, 5 pi by 8, 7 pi by 12. 7 pi by 12. Are you getting it? That is where again it is becoming 0. And then pi. Because if we put 3, right? Okay, if we put 3, are we getting one more interval? No, that's it, right? Okay, this is what it is. This is what positive, this is what negative here. So it is becoming like wavy curve method. If we make here like that, it is positive, positive, negative here. So it is what? Interval for increasing, strictly increasing into what? 0 to pi by 4 union 7 pi by 12 to pi. Okay. Let me know if you're not getting the answer. I'll give you the answer next class. Okay, proper, right? Okay, but I think we got it, right? 2 points are there where it is becoming positive and negative. Clear, guys? Does it make sense? Decreasing for this interval, increasing for this. Hello? Everyone got the same? Mehak? So not only pi by 4, there is one more point, right? Okay, we need to check for that also, right? No? It is becoming, we need to find out those critical points where it is becoming 0. For what all points it is becoming 0. So we are identifying from here, n equals to 1. If I put no, I'm getting what? Pi by 4. N equals to 2. If I put, I'm getting what? 2. If we put, we are getting what? 7 pi by 12. That is what? These are the 2 points. If we put n equals to 3, we are not getting, right? Okay. We can have a third point, n equals to 3. Okay, let me check. N equals to 3, right? Okay, because 3 pi by, here, 3. So pi minus pi by 12, right? That is also you're saying. Yes, then to one more interval. But why option is given for only 2, right? Yeah, it is becoming 11 pi by 12 also, right? That is also in the interval. Yes, yeah, Prithvi, right? I'm getting that also. Right. Then options are given wrong. Okay. They are saying strictly decreasing for this. Then there is some mistake in the question. Okay. Exactly. Pi by 12, this is also 11 pi by 12 also we are getting. So we'll get this, these two interval for increasing, and then union here, what we need to do, pi 11 by, okay, Prithvi, yeah, right. This will be the answer then, right? Okay. What we'll get? 11 pi by 12. Do it, everyone. Okay. And let me know you're getting it or not. Okay. This is what, this is also it decreasing. It will come. There is one more point. It is coming, right? Exactly. Think about it, everyone, right? But you can please explain wavy curve method. I'm confused. Wavy curve method is what? Okay, wait. Let me just quickly explain what is wavy curve method. Larry is saying I'm confused about wavy curve method. Wavy curve method for any function, right? Okay, suppose this x minus 2, x minus 3, or like, okay, there are few things. The wavy curve method is a little longer. Okay, like, okay, if I consider all the points, but what we say, like, okay, suppose I want to make it positive or negative, right? Suppose this is what the expression. So we make the number line here, Larry. In short, if I explain, this critical point we write where it is becoming 0. So 2 is there, 2 is 1 point, 3 is 1 point. In between, after this point, okay, what it is? This expression is becoming positive. In between these two values, it is becoming negative. Before this 2, it is becoming positive. So that's what we say, like that it is becoming. This is what wavy curve, like that. Positive and negative, positive. So here, did you get it?
Yes, sir. This thing I got it. Can you explain the less than 0 condition? But
Less
x
than
minus
0? Acha, okay. Okay, for see, less than 0 is nothing different, right? Greater than 0, we are having this interval and this interval. Suppose same expression is given for this. Same expression is less than 0. So then we'll choose this interval because that is where it is negative. That's it. So for this answer will be what? X belongs to 2 to 3. Here answer is what? X belongs to minus infinity to 2 union 3 to infinity. That's it. Because we were looking for positive here, right? And we were looking for negative here. That's it. Got it or not?
Yes, sir. So basically always From the left or right most, it's going to be positive, negative, positive, negative.
Yes, but you need to make sure that here it is positive sign, here also it is positive sign. If it is like 2 minus x, you need to change that. Then only it is what it will be like this. Wavy curve will be like. Correct. We always start actually from this side, right? In wavy curve, we always start like that, right? And now we will see, okay, if 3 points are there, so we need to cut them, right? And then we need to go back. Like here, like we can't go up right now. We will go just down only like that, right? Are you getting it, Larry?
Yes, sir.
Like in this case, how many points we got just now? 0 and pi. We want to observe between that. Now I got pi by 4 point. Then I got, what was the other point? 7 pi by 12 I got. Then I got one more point, 11 pi by 12, right? So now here, what is happening? It is positive here. It is positive here. Then it is what? Negative here. Sorry. No. Here, actually, wavy curve. Okay. In this case, this is what tan. In polynomial form, it will be always like that. But in tan, it is what? Positive here. It is what? Positive. We don't know what is happening before, but it is positive here, then negative. It will be alternate. That is what we can have. Wait a minute. Why it is not coming? 0 to, yeah, correct. Okay. Correct. Now positive here, 2 intervals and 2 intervals for negative. That's it.
Okay, sir.
Yeah. Odd पे curve का layer change होगा. Even पर continue. Yes, odd power पर. You mean to say odd power, right? If it is whole square, Varun, then we don't change, right? I know, right? Okay, that is different thing. But linear form and all, that's what I'm saying. Like wavy curve is like too many exception things are there. So that is what we learn in basic maths, right? So if you need that also, guys, okay, no problem. We can have one class for that, but yeah, you need to remember for that, like that is also needed for this type of question. Okay, I know it is time. We need to continue this next class, and next class will be like LPP, linear programming. So we can add to this topic also there. Okay, fine. If any doubt is there, you can ask next class. No. Okay, bye bye guys. Then take care. All the best. Keep studying. Thank you very
Yes,
much.
bye, sir. Thank
Yeah,
you, sir.
bye. Thank you, everyone. Yeah, Raj, any doubt here? Thank you. Bye.
No, sir.
Okay. Bye then. Gautam was
Hi everyone. Good evening. How are you all? Mic is bloated. Bloated as in, like it's very high. All right. Is it better now? Yeah, is my voice audible? Better? Great. Good to hear that. Oh, it's way better, Dhruvi. Thanks for asking. It's healing. All right. So how's your prep going on? Now the exams are quite near. Just 1 week to go. Tension? Yeah, like tension must have started now, isn't it? All the things that you have to do, plus some people might be also going to school for their labs and other things. So are the things going good? Mock practicals, yeah. For physics with, oh, and OMR practice. Oh, good. So that's very important because this is like the first time CBSE is going to conduct it, no? So of course it's very important for them. No, Brittany, not at all. All right. Oh, I'm doing good. How about you, Brittany? So let's get started with our discussion today. Yeah. And today's discussion is about organic. Now, one of the major things which is a setback for almost everyone. Organic. Here I come, Brittany. Hanji, so organic is like literally one of the most important things. And the entire 12th grade organic relies on your 11th grade organic. This thing you might have realized by now. So most of the teachers who have been till last year saying this, that this year, do this time, this is very important, this and that, and so you might have realized that half of your 12th, almost half of your 12th is based on organic chemistry. Ki part 2 book is purely organic, and this organic is like application of what you have done in 11th. So it's basically nothing else but an application of GOC, grade 11, which is generally taught towards the end of the year. Hannah. So most of us loses either the interest, either we lose interest, or we find it boring, or the teachers just complete it for the sake of completion, like in most of the schools, I believe. Okay. So this is like a very common observation from where we have seen and observed. Good evening, Aryan. That what I have observed in students is like they are quite afraid of organic. Unse bahut simple, basic organic questions bhi they cannot solve because they're too afraid of it. Good evening, Prithvi. Right, so that's like one of the most important stuffs that we are going to talk about. And today's discussion is mostly a discussion of simplification of the basic organic. Now, here we are going to discuss in general things about organic chemistry related to your term 1 examinations. So in your term 1 exam, I guess there are 2 chapters coming: haloalkanes, haloarenes, and alcohols, phenols, and ethers. Right. So for your term 1. Okay. Yes. On biomolecules is indeed there, Shashank, indeed. It's not exactly organic, but yeah, it's a part of it. So yes. Technically, we don't consider exactly biomolecules, polymers, and chemistry in everyday life exactly as organic, but they are derivatives of it. So they're derivatives of it. Yeah, so major two chapters which are actually coming are haloalkanes, haloarenes. And the next one is alcohols, phenols, and ethers. Now, if I talk about the importance of these chapters, so if you look at your the basic CBSE, yeah, so they have given equal due to all the 3 organic chapters. All right, so it's like almost 15. So this is 555 ka division hai. So that is like the basic organic division. Now, if I talk with respect to JEE, okay. So in JEE, so that is your IT examinations, this chapter is having a weightage which is lying nearly 1 question per paper for means. And as far as advance is concerned, then the weightage goes from 0.8 to 1.6, depending on the interlinked questions. But when it comes to alcohols, phenols, 1 question mostly is from the JEE part, but when it comes to advance, it's nearly 1 to 1.9. So almost 2 questions, almost 2 questions can be done with the help of this particular chapter. Now, the major importance of haloalkanes and haloarenes, also known as alkyl halides and aryl halides, this chapter finds a major importance when it comes to the usage of this. So they generally don't ask a direct question on this. They asked an interlinked question on it. Yes, things based on conversions, those roadmap questions, A giving you B, B giving you C, or one reactant giving you a product when there are multiple reagents used. Like 7-8 reagents wo beech mein rehte hain, and then there is like a conversion from reactant A to product B. So these are the kind of questions where you will find the maximum usage of this chapter. And that is the major requirement. So this chapter has to be known, irrespective whether I get a direct question on it or not. This chapter is an utmost requirement, right? And as far as the real life thing works with the haloalkanes and haloarenes, oh, this is so common, tincture of iodine, right? Chloroform. Okay, in my classes, I always used to say, this is chloroform is like garib kidnappers ka reagent, you know? Because nowadays no one else uses except for garib kidnappers. So this is the thing. So chloroform, this tincture of iodine, Dettol. Okay, so you use these CFCs. Okay, whether they're good, whether they are bad, they are highly used in our day-to-day life. Fertilizers, DDT, everywhere you'll find the usage of this particular chapter. Whereas if I talk about alcohols, phenols, and ethers, again, a very common example is sanitizers, your basic glycerine, which you use, okay, whenever you have those swollen mouths. Now, those phenols, which you're using for your floor cleaning, alcohols are also used in your cough syrups, drinking purposes. So the market is very wide. The market is really wide. Okay, so this is like the daily life usage of this particular chapter, which is again very important because it is very important to understand that why are we reading these chapters? Like, where do we practically find the importance? So the practical importance is industry. So you go to medicine industry, you go to cleansing industries, you go to textile industries, you go to dye industry, printing industry, you will be finding the usage of all these compounds, right? And that's why chemical engineers mostly find jobs anywhere in the industry. Because any which ways, kahin na kahin, kisi na industry mein, they will get fit inside. So that's how it works. Right. Now, the question is, what are we going to learn in today's lesson, in today's lecture? Okay. So this is like the major aura of the things that we have discussed, where we are trying to know that how are we finding these chapters useful. But how do we use these chapters in our questions for our understanding purposes? Right. So for that, there are few things which we need to learn, which we need to understand, few basics. For example, if you talk about your CBSE examinations, mostly CBSE is going to ask you the expected type of questions. Are those roadmap questions, which can come as a part of your case study questions. So the case study questions has further few points, like question number 1, 2, 4, 5, which you have to do comprehension based. So they can give you an entire roadmap thing with an information initially, and then they can expect you to find out what is P, what is Q, what is R as like subparts of those questions. Right. Second, a very common thing which CBSE had been asking are conversions. But of course, this year, because of the MCQ based part, conversion is not an easy thing to find it out, because this time they cannot ask you to do that. So in order to check your conversion abilities, again, one way is to ask you a roadmap question to know what is the purpose of a reagent, right? Second way, as Dhruvi said, is to know the purpose of, again, the reagent. Now, what is the difference? The difference is in the first question, too right, Harini, or too easy. Mostly like the questions which I think you will be expecting is like general questions, not very deep questions. You cannot expect, but mostly, yes, keep your isomerism in mind, because I believe isomerism and chirality will be the two things which will be asked in your CBSE, definitely. Okay, because they know that students have forgotten their 11th grade basics. They know the fact. So they can target you on the basis of it. And chirality, any which ways you have just learned in haloalkenes. So this is one point where they would be judging you. Another place where they can judge you is nucleophilic substitution, because if you'll see your exemplar book, you'll find numerous questions on nucleophilic substitution reactions, which signifies because NCERT exemplar are majorly framed by the same body. So that means they are going to give this part a due advantage and a due respect. Right. So which sort of substances or substrates are going to react fast in SN1, SN2. So you just have to worry about carbocation mechanism and steric hindrance factors, those kind of cases. Now in the roadmap question, there could be a case where A is converted into B using a reagent, let's say PCl5. Okay, so in that case, you have to, let's say, identify B. Whereas the second kind of question is that, yes, A is giving you B. The first one is A is treated with PCl5 and you have to identify the product. Second case is A is giving you B. This is given. You have to identify the reagent. So by these ways, they are going to check your conversions. Right, this is going to be their major things. Third, which has always been the case of CBSE, is distinguishing part. Now, usually CBS2 used to give like almost 3 marks they used to keep in your board examinations for distinguishing tests. Like in your case, it could be Hydroform or Lucas reagent, Victimia. These are the tests you are having as of now. So when you talk about these distinguishing tests, they're very important. And they this time can be asked on the basis of MCQ part. Not a case study, but they could be a basic MCQ question. Okay, again, with respect to like which is fastest, which is slow, when the turbidity is quick, when the turbidity is weak, which of the following 2 pairs can be distinguished by some reagent is given, bromine water or anything is given. Fourth are reason-based questions. Again, very common questions of CBSE. Till last year, like when CBSE used to be purely subjective, they used to award 3 to 5 marks for reason-based questions, right, from organic itself. Now, this year, of course, they can ask you, but in a different strategy, and that is assertion reason, which I know is going to be tough for you. Remember, first and second option is like the major problem. So that's going to be the scenario. Now, let's talk about how to do these questions or how to work on this part. Okay. Now, first thing that I'm going to discuss is like the conversion scheme in case of haloalkanes and haloarenes. So I'll be taking everything one by one and I'll try to cover the maximum things in this part. So first thing is the conversion scheme. Okay. For instance, if you talk about any alkyl halide, so when you talk about this chapter from your NCERT point of view, so I think they have given a few things like major information that haloalkanes and haloarenes are formed by the substitution of one hydrogen with a halogen. Now this halogen can lie on sp2 hybridized carbon or sp3 hybridized carbon. Yeah, this is what they have informed. If you remember, then they say like basically a hydrogen has been replaced by halogen in alkene part or arene part. Now, when this halogen is lying on the haloalkane or arene, then there are 2 cases. The 2 cases could be like this distinguishing or this classification is done on the basis of number of halogens. How many hydrogens have been substituted? So on the basis of it, you call it as monohalo compound. For example, this one. So there is only one of the hydrogen which is substituted by halogen. So this is monohalogen, monohalo compound, dihalo compounds if a compound has 2 halogens present in it. Right. Trihalogen compounds or trihalogen derivatives, polyhalogen derivatives, etc. The second kind of classification is done on the basis of the type of carbon. So type as in the hybridization of carbon on which the halogen is getting attached. The hybridization of carbon on which halogen is attached. Now, since we are talking about organic molecules, so definitely there could be only 3 hybridizations possible: sp3, sp2, and sp. Right, because it's carbon, which is acting as the central atom, and this atom does not have a d orbital, so d related hybridizations are not possible in this case. Out of the 3 cases, it is these 2 cases which are of prime importance to me. When the carbon to which halogen is attached is lying on an sp3 hybridized carbon, right? If it is on a sp3 hybridized carbon, again, it can form a haloalkene like this. These are the only carbons I'm drawing. Of course, you can complete the hydrogens. Okay. Second case is allyl compounds. And third case could be benzyl compounds. Because I have to make sure that my halogen must be attached to the sp3 hybridized carbon. Oh, the second one is this. This is also sp3. This is also sp3. Make sense? This part? It's a basic part of your NCERT. Okay. Now when you talk about sp2, so in sp2, again, there are 2 cases. First case is vinyl. Where it is directly connected to sp2. And the second case is aryl. When the halogen is directly connected to the benzene. Is this part clear? Yep. Basic discussion of it. Oh, wonderful. Now, other things that your CBSE textbook talks about after these things is the nomenclature, isomerism, and the nature of the CX bond. Yeah, that it is polar because of the electronegativity difference between carbon and halogen. And of course, because of the electronegativity difference, you can experience the inductive effect. Okay, it is polar with lesser solubility in water. Yes, but it has a dipole moment, which decreases down the group. And here an exception comes up, if you remember. Okay. This is benzyl. Okay, Aaron. Oh, no, Abhin Raj. So benzyl means when a carbon is connected. So like benzyl alcohol, benzyl chloride, anything. CH2 has to be connected.
I mean the next one, ma'am, an sp2.
If you are speaking, which I cannot hear you, 1 second.
You can hear me?
Yes, now I can.
Ma'am, I was telling about the second one, ma'am, where you just wrote vinyl and then aryl, right?
Yeah.
There, can't we say that's a benzyl ring rather than
you can call it as phenyl ring, not benzyl.
Vinyl ring.
Benzyl is
due to Cl.
No, not due to Cl. C6H5 is phenyl. Now, anything could be connected here. It doesn't matter.
Yes, ma'am. Only if H was that instead of Cl, then benzyl.
Yes.
Fine, ma'am.
Now, if you talk about this, the next part related to this. Now, what we need to understand over here is that the CX bond, we were discussing that CX bond is polar, right? where if you talk about the dipole moment, since it is polar, this part is negative, this part is positive. So dipole moment is Q into D, charge into the distance between the two charge particles. Now, if you talk about CF to CCl to CBr to Ci, I'm expecting that the dipole moment should decrease. Okay. But if you'll check your book very carefully, there's an exception here.
That's because chlorine is an anomaly, right? Because it's a smaller compound.
Chlorine is an anomaly because
because it's a smaller compound, it's highly electronegative, and there's also electronic repulsive forces, right?
which is in fluorine.
Yeah.
Yes. So basically, when it comes to chlorine part, again, this is the only case where size is the dominant factor. So if size is the dominant factor, then distance is the dominant factor in this case. All right. So this is the only reason why this increases initially and then it further keeps on decreasing. Though the difference is not much. If you'll check your NCERTs also, books also with proper data, you will find that the difference is not much. But yeah, it is still there. All right. So this is the part, and of course, this could be a question because it is actually NCERT, but it is reading in between the lines of NCERT. Right? So that's how JEE is going to ask you the questions. Now, again, as I discussed, after that, there is this nomenclature isomerism. So there are like a few good questions in your NCERT, particularly the in-text questions. So please do each and every in-text questions very carefully and very nicely. They're really, really good. Okay. Now, I'll talk about the next thing, and that is your general conversion scheme. So if I talk about any alkyl halide, for example, this is my alkyl halide. Now, the best part about this is like if I have to do any sorts of conversion. So how can conversion mean converting one functional group into another? Okay, one type of substance into another category of organic species, another classification of organic species. For example, if you probably would be knowing, or I'll better take for your simplicity version. I'll take this part for better understanding. Now, if I treat it with alcoholic KOH, what will I get? An alkene. Elimination reaction, and I will be getting an alkene. And alkene, I think I can do further reactions on alkenes, right? So there could be anti-Markovnikov's addition that I can do. I can do a Markovnikov's addition on it. I can convert it into an alkyl halide of different sort. I can convert it into an alcohol. I can convert it into an aldehyde or a ketone. Remember ozonolysis. So, another. So there are further many reactions which I can do on an alkene and do my conversions further. Whereas at the same time, instead of using an alcoholic KOH, if I use an aqueous one, then, right, Bhumi, a substitution reaction forming an alcohol. So here, it's simply that my number of carbons will remain the same and I'll get an alcohol. So in both the cases, my carbon number have remained the same, right? This part, I have not touched the carbon number. Yeah, so basically chlorine got substituted with OH. Right. Okay. Now, if I talk about this particular part further, okay. So, see, like as we were discussing, if I'll treat it with bromine, right? And then in the presence of it, like there will be a vicinal addition. Then I can further use this vicinal addition will be an anti-addition. And this, when is further treated with alcoholic KOH in the presence of NaNH2 or sodium and liquid ammonia, then I can get an alkyne too. So this is a further usage. I can convert it into a different substituent. Now, same way here, I can treat it with copper at 573 Kelvin, and with keeping the same number of carbons, I will get an aldehyde. This is a reaction, if I'm not wrong, you have done in your alcohols, phenols also. Yeah. Okay. Now, again, if you will treat it with KMNO4 in acidic medium, then it will get converted into a carboxylic acid with the same number of carbon, mind it. The carbon numbers are not changing at all. So basically it is the last carbon, the carbon which is bearing the OH. That carbon which is bearing the OH, that will get oxidized. Right? So this part. Even if you treat the aldehyde with a mild or strong oxidizing agent, doesn't matter. It will get converted into carboxylic acid only. Yes. I'm going to create almost every compound, every type of. When we do KMNO4 in the basic medium, so that is Bayer's reagent. From there you'll get a diol, and that you have to do on alkene. But mild, yeah, strong oxidizing agent where you can use here KMNO4 in the basic medium also, it will do the work. It will do the work, but you shouldn't use it. Okay, ये बात shouldn't use it. ये बात तुम्हें तब समझ में आएगी once you'll be done with the aldehydes ketones chapter. If you have done it, then it's great, because in that, if you'll do that chapter, you'll realize that aldehydes and ketones having an alpha hydrogen also undergo a reaction known as aldol condensation. So when you use KMNO4 in the presence of basic medium like NaOH, तो वो aldol reaction हो जाती है, reaction का path ही बदल जाता है, इसलिए that is not suggested. Okay, this part clear? यहाँ तक aqueous, एक U stands for aqueous KOH. acidified KOH कैसे हो सकता है? Acidified तो मतलब एक acid है, KOH तो खुद ही base है, so there will be an acid base reaction, no, in that case. So there's nothing like acidified KOH. Alcoholic, ALC is for alcoholic.
That is beta elimination, right? CH
For
alcoholic AOH.
yeah, that's beta elimination. Done up till here? Okay, not an issue. Yep, chalo. So let's move to the next part, next conversion. Acha, tell me, you all have heard about this pyari si cheese called magnesium, hai na? So when you use magnesium in the presence of dry ether, what do you get? A Grignard. Perfect. You'll get a Grignard's reagent, which is also known as your organometallic compound. Yeah. So I think I can do this part also. I can treat it with magnesium in the presence of ether. And what I'll get is Cl और कार्बन के बीच में मैग्नीशियम आके इंसर्ट हो जाएगा. A Grignard reagent, which is a very good reagent. Oh, I should write the full form. Now, yes. Now, this is the part from where the number of carbons can change. Because Grignard is a part of a reagent. Since it is a reagent, it is not a substrate anymore. Getting it? So substrate is that part of the reaction on which the reaction, organic reaction is taking place. That is the reactant. वो surface provided है. इसका मतलब substrate is the major substance who's providing you the number of carbon atoms. Substrate provides you the major number of carbon atoms, like the substrate on which the reaction is taking place. Reagent can also provide, but it can or cannot provide. Right? It can or cannot provide. For example, if you talk about, let's say KCl, here it is providing its carbon. But it is not mandatory that every reagent has to provide carbon, like aqueous KOH, alcoholic KOH. They were not providing carbon. Right. So here you can see there is an addition of carbon. One carbon extra. Right. And yes, तुम्हारी प्यारी NCERT ने AGCN भी लिखा है, where they have said कि now you are going to get NC. So that is isocyanate. Right. Now, if I talk about this Grignard reagent, so this Grignard reagent is a reagent which I can treat on anything, right? Whereby anything I mean, because in Grignards, you can look for a positive and a negative center. So it can easily undergo an addition reaction. Okay. This is the negative center and this is the positive center. Carbon is acting as a negative center. Magnesium is acting as a positive center. So this is a reagent which generally shows addition reactions. Addition reactions we know is a property of unsaturated compounds. So that means it can easily react on unsaturated compounds. It's a property of addition reaction is a common property of unsaturated compounds. For example, it can react with an aldehyde. I'll take a very simple aldehyde like HCHO. A very simple aldehyde. I can take CH3CHO, anything. Right. And I can think about its electromeric effect. This is the negative part, this is the positive part, and I know opposites attract. So this negative will go here, this positive part will go here. And as a result, I can say that this CH2, this CH2, this CH2 is connected to the carbon, hydrogen, hydrogen, O and H, depending if I have further treated with acidic hydrolysis. Right, in which case I'll get primary alcohol. Right. Also, I can treat it with another unsaturated compound like ketone. Simplest being this one, which is going to yield me a secondary alcohol. You can draw the product by yourself. Can you? I can treat it with carbon dioxide also. What will I get? Hey Bhagwan. हाँ मैं पूछने वाली थी एग्जैक्टली थैंक यू आर्यन अच्छा नहीं था थैंक यू आर्यन कोई तो है जिसने जेन्युइनली सोचा इतनी देर से आई वाज वेटिंग कि कोई तो बोले मुझे भाई मुझे एक बात बताओ कहां से सेकेंडरी कीटोन के साथ रिएक्ट कर रहा है तुमने मजाक है क्या सेकेंडरी थोड़ी देगा टर्शरी नहीं देगा दिस इज टर्शरी तो फिर सेकेंडरी कहाँ गायब हो गया नहीं ज्योति ऐसा कुछ नहीं बच्चे ये एक जनरल चीज होती है दिस इज लाइक जजिंग द पीपल कि वो कितने सीरियसली क्योंकि रात का टाइम है ना मोस्ट ऑफ द स्टूडेंट्स आर स्लीपिंग other aldehydes will give. So this one was the simplest aldehyde where both the sides are having hydrogen. But most of the aldehydes have one side as R, the other side as H. Right? So technically HCHO is an exception. HCHO अपने आप में एक exception. But वो exception है नहीं. उसका बस logic है that there are two hydrogens on both the sides. So उसकी ये problem है. That there is no R part connected to it. Okay, but rest any other aldehyde is having some R. Right? So ये जो R है, this is the reason why it will become a secondary alcohol. Right? You all have done it. It's a part of your regular NCERT. And it is carbon dioxide with which it gets maximum oxidized and it starts giving you a carboxylic acid. All right. Anyone having any doubt? If you want to know any mechanism or anything, just let me know. But this is how the things are working. Yes. So this carboxylic acid is being made because of the fact that two OH are not stable on the same carbon. So being two OH, one F, or two NH2s or OH and NH2, सब कुछ कोई भी stable नहीं होता on the same carbon. Yeah, why not? So basically it is like same stuff. C double bond O double bond O. So on one side, you can have the electromagnetic shift. This is negative. This is positive after that, after the shift. Right. And then what will happen? There will be a formation of, you see, RCH2 is there. Then CH2 is the one now with a negative charge who is going to attack the carbon, which is positive. So this carbon is already having a double bond O and an O negative. अब यहाँ पर what happens? H plus and H2O का hydrolysis कर दो either directly. So in that case, you will get this part, either. Otherwise, there is a second attack of Grignard. Okay, there could be a second attack also, which is possible in this case. All right, but most of the time, we generally do the first part. Most of the time, we generally do this part and you'll get your answer. The second part gets complicated enough. All right, this part. Yes. Okay. Now, हम लोगों ने alkene और alkyne तो बना लिया. Can we make an alkane out of it?
Dehydration reaction.
Sorry, which reaction?
Dehydration.
Dehydration. For which part, bachche?
For alcohol.
From alcohols. Okay, from there you'll get an alkene. Dehydration.
From reduction, you can get an alcohol. So then from there, you can dehydrate.
Indeed, indeed. So we can do that. So we can use an alcohol and convert it to an alkene. And then alkene I can further reduce using hydrogen in the presence of nickel. Right. So either I can do that. But same way, if I want to have this sort of reaction, again, it depends on me whether I want to have the same number of carbon या क्या करना है मुझे. So if you want to have the same number of carbon, you can use alcoholic KOH and then do the reduction. And you will get an alkene with same number of carbon.
We can use a LiAlH4 also.
No. You can't. You can use rest phosphorus though. Like by converting into it first into OH, then you can use red phosphorus.
No, like from carboxylic acid to alcohol.
From carboxylic acid to alcohol. Now, another way is, you remember Woods. So you can use Woods reaction and have a symmetrical, but exactly double the number of carbons. And that's also an alkene. Right? Now, if you want to increase 1 carbon or 2 carbons, in that case, what you can do, you have a cyanide, right? If you use acidic hydrolysis, in case of a cyanide, you already have increased 1 carbon, right? So it will give you a carboxylic acid again, but this carboxylic acid is having 1 extra carbon. And now you can do the same stuff, like you can reduce it to CH2OH and then do the same thing. Then convert it into alkene, then convert it into alkene. So that way you can just look for the fact that how many carbons do you actually require in the final product. Okay, same way, if you treat this cyanide part with, let's say, LiAlH4, which is a reducing agent, in that case, you will get an amine. Stephen's reduction will give you an aldehyde. This is just going to give you an amine. So for Stephen's reduction, we use SnCl2 basically. So this is an amine which I am getting. And this amine is actually primary amine. But if I'll treat NC part with LiAlH4, then I'll be getting a secondary amine. Now this secondary amine is like with 1 carbon extra or with N-methyl group. But if I treat this part with acidic hydrolysis, right, then I'll be having the same number of carbons as were present in my reagent, where there is an amine which I'm getting. I'm getting a primary amine in this case. Because this is the bond which is breaking. So I'll get a primary amine. And this carbon gets converted into HCOH. Here, the other part was ammonia. Right? Does this make sense to you anyhow? Though, yes, there was one more reaction where you can directly treat it with NH2. Or like, not exactly NH2, ammonia, and you can directly get the answer of NH2. So that is also there. Ammonolysis. Yes, true. But the problem with this reaction is that it is a chain reaction. So you'll get multiple products and yield decreases. Because of multiple products, the yield decreases. So it's not a very wonderful process. Ammonolysis. That's acidic hydrolysis. The side product is an acid or an aldehyde. Acid. You can further treat it with nitro. And you can get a nitro pad also. Hanji, is this part clear? Up till here? So you are able to create any organic compound out of an alkyl halide. This is the part which you use during your conversion schemes and data related questions, those roadmap questions. Major process is this, which we have to use. All right. Now, the way we have created for alkyl halides, same way we can have a conversion scheme for aryl halides too. Right? That is for phenols. Okay, so shall we start with it? All right. No doubt. In substitution reactions, given any reagent, how do we tell if it will follow SN1 or SN2? Wonderful question, Pranshu. Most of the times, either it should be given, or like if I talk about aqueous KOH, it is like a known thing. It is going with an SN1 reaction. But otherwise, there are different reasons. For example, you have to look for the solvent. If it's a polar protic solvent, then SN1. Aprotic, SN2. Okay, or you have to look for the substrate, like tertiary substrates, if there is. So SN1 reaction will be favored. Primary substrate, and if that is forming a product, then SN2. It is the secondary one where we majorly gets like a little fumbled. Okay, where we do not decide, we cannot decide. So look at the reagent in that case. That's concentration, temperatures, indeed. Like most of the cases, if I talk about concentration, like SN2. So 2 is like, it's bimolecular, so it is dependent on substrate as well as the reagent concentration. Whereas SN1 is only dependent on substrate, though it doesn't matter because that level of information must be given, right? Strong nucleophile, yes, then SN2 is more favorable, indeed, Pranshu. And if it is a weak nucleophile, then SN1 is more favorable. And by weak and strong, we just mean with respect to lone pair. Like if H2O is given versus OH negative is given. So H2O is a neutral one, so SN1. OH negative is strong, SN2. Yes, SN1 gives you racemization, SN2 gives you inverted product, but that information must be given for that. Yeah, it is not that I look at a reaction and I can identify. That I cannot do. Experimentally, I have to check. Clear? All right, in that case, let's move to aryl halides and let's see how their conversions are working. So, for example, if I talk about chlorobenzene, this is my haloarine. And let's see. Oh, indeed, it is resonance stabilized. So very common reason-based questions. So in this chlorine, to be it aryl halides, be it vinyls. No. Substitution is not a very common reaction for it. The major reactions which are shown by aryl halides are aromatic substitution reactions are there, but there are very few, like in Dow's process working via benzene mechanism. But this is not a characteristic reaction. The characteristic reactions will be always electrophilic substitution, not nucleophilic. Electrophilic substitutions, where chlorine is an orthoparadirecting in case of substitution. So if you talk about electrophilic substitution reaction of it, common reaction. So chlorine's behavior is orthoparadirecting. That is the behavior. All right. Another reason-based questions, जितने भी इसके ऊपर बनते हैं वो, the second type of reason-based question would be that there's a partial double bond character because of resonance. So whenever someone says, "Na CCl bond, why is it not breaking?" Like you can just close your eyes and give this answer anytime, any day. It will
Partial
be
double bond.
partial double bond character due to resonance. Right. All right. So if I talk about the first part of the reaction, let's say, it's like, just like we have the alcohols, the same way we can talk about the these molecules or these reactions also working. For example, a common process is Dow's process, as I just said, where I treat it with NaOH and then I do acidic workup. So in this part of the reaction, I will be getting phenol. This is a name reaction, Dow's process. All right, and this reaction occurs via benzyne intermediate. So the process is a little different. It's a nucleophilic substitution, but it occurs with a very different mechanism incorporating a benzyne intermediate. Right. Vigorous conditions. Dow's process requires a lot of pressure and high temperature indeed. Devashish. You require strong pressure, almost 623 Kelvin temperature, 300 atmosphere pressure. Okay, and you can lower down this value. You can lower down this high temperature and pressure conditions if you start using an electron withdrawing group, because it's a nucleophilic substitution. So if you want a nucleophile to attack, you just have to make your substrate more eased out, right? And for that, you can just use a electron withdrawing group like nitro group to decrease the electron density. Indeed. I doubt. Amen. No, I don't know it is. Yeah, it's not. All right. Hanji. So next thing is the next part, which is CuCN, right? Now, if you talk about CuCN, what will be the final product? Hanji, what will be the final product? CuCN. Okay. Pyridine is also present. The temperature is high. Temperature is quite high. Okay. So in that case, you will get again a nucleophilic substitution reaction. Isocyanide totally milta. Isocyanide is a very specific reaction. You remember with carbylamine test. So that is a very specific one, majorly. It's a carbylamine test, which is done with the help of primary amines when treated with chloroform in the presence of a base. So here you directly get cyanide. And of course, if you're getting cyanide, I can do the further conversions. So here, I was getting an alcohol. Here, I'm getting a cyanide. And I can convert this cyanide into, of course, the same stuff, which I've just done. If I'll do acidic hydrolysis, I'll get benzoic acid. And if I'll do reduction, I'll get benzylamine. Yep, makes sense? This part up till here. Then I can easily create a Grignard's out of it. Okay, easily create a Grignard just by treating it with magnesium in the presence of ether. Yep. And you know this Grignard reagent is finally a very wonderful reagent. It can give me a lot of different kind of species. Yeah. Then we talk about the next thing. Even I can prepare a direct amine or aniline from it by treating it with ammonia in the presence of copper oxide. Even with KNH2, yes, you can use KNH2. KNH2 के साथ, again, this is benzene mechanism. Do these reactions come in further chapters? Yes, Aryan. There are major 4 chapters of organic. These 2 followed by aldehydes, ketones, carboxylic, and amines. Like the same reactions keep on repeating. Okay. And hydrocarbons. So these 5 chapters where hydrocarbons you have done in 11, these 4 you will be doing in 12. These 5 chapters की सारी reactions जो हैं, they are repetitive reactions. Yes, most of the reactions. There are few name reactions which are quite specific for it. Okay. But otherwise, when you till the time you'll reach amine, you'll be like most of the reactions you know. Okay. It's like how it works. All right. Then we have these reactions where you can talk about Woods or Woods-Fittig. right? So you can treat it with like CH3Cl in the presence of Na, let's say. That Fittig or Woods Fittig one. So this one will give you. Now the purpose of Fittig reaction or Woods reaction is to increase the carbon chain length, right? This is the same purpose of Grignard's also. It is to increase the carbon chain length, right? So basically what is it doing? So this is one part is alkyl halide and one part is aryl. So it is Woods Fittig reaction. And where when you are just using two aryl halides, then it is Fittig. And you get a diphenyl ring here. Or you call it as a biphenyl ring. Oh, name reactions are very, very important in this. So all these reactions like Sand-Mears and Gattermann and Finkelstein, Swartz, Darzin's reaction, Roof's process, this Friedel-Graf's alkylation, acylation, जितने भी name reactions are ना, they are going to be highly, highly important for this chapter. Bell-Schiemann, whatever, like, think of it. If there is a name reaction against a scientist, yes, it is going to be important. All right. Now, then, of course, there could be a reduction. For that, you are using a reducing agent. For instance, if I treat it with nickel aluminum, so basically a metal in the presence of base, this is a reducing agent, and with reduction, I'll be getting benzene. Back again. Okay. Now I can use chlorine in the presence of dark and FeCl3. In that case, I'll be using its orthopara-directive influence, and I'll be inserting another halogen. Right. Whereas if I had this sort of molecule, and then if I'm adding chlorine in the presence of light, free radical, right? Because I'm using light. It's going to be a side chain reaction. Make sense? So you have to look at the conditions properly. Conditions are really, really important. Cool. Now, let's move to the next. Temperature condition 0 to 5 degree was for this aniline disonium reaction. All right. It was for disonium reaction. 0 to 5 degree temperature. Now, again, like same sort of reactions. Again, if you're treating it with nitrating agent, there will be nitro group coming. If you're treating it with sulfuric acid, it's a SO3H group coming. plus para product. We treat it with concentrated HNO3 in the presence of H2SO4. Then nitro group. If you treat it with in the presence of AlCl3, RCl or RCOCl. So accordingly, you will get R part. Alkylation and acylation for Friedel crabs. So you can see like the varied kind of things that I can add to it, the conversions I can make. Right? So again, this is the major conversion scheme that we are having. Does this part make sense to you? Yes. All right. Yeah, note it down. Yeah. All right. अब ऐसे ना, there are few of the distinguishing things which also like very frequently asked. For example, एक बड़ा ही common distinguishing test होता है out of RCl versus RBr versus R. Okay, like what sort of compound are you given with? Are you given with RCl or RBr or R? So how do you do this sort of distinguishing? This sort of distinguishing, how do you do? RCl, RBr, RI.
It undergoes fatigue, Wurtz fatigue, or Wurtz reaction, like the halogens, the haloalkanes. Yeah.
Like it will undergo or not undergo?
It will
How-
undergo Wurtz fatigue, or
No. How does that it has to do anything with chlorine, bromine, or iodine? So I'm saying that there is some R group. The R group is common. There's like chlorine, bromine, and iodine which is present.
oh, okay, then we use SN1 or SN2 and then observe the gas evolve.
Nahi. So yeah, it is based on like some part of the rate of reaction is dependent on the like leaving group tendencies, but not precisely very nicely. Yeah, to an extent, Bhumi, you're right. Light. Okay. Do you like have you forgotten that dilute silver nitrate test? Silver nitrate, when you treat it, RCl when is treated with AgNO3, can I say it will get converted into AgCl?
Yes.
That's it. Work done. So basically, if I want to check the difference between RCl, RBr versus RI, so I'll treat all three of them with dilute AgNO3.
Ma'am, but that only eliminates Ri in the truth, right?
No.
Because RBr, I mean AgBr and AgCl both form a silver mirror, right?
नहीं बच्चे, you are talking about tolerance reagent. ही tolerance reagent थोड़ी होता है.
No, but then it forms AgCl, right? Which then
And just
on sunlight breaks down into Ag and Cl2 plus.
but then why am I? Who said that I'm taking it to sunlight? Why do I have to take it to sunlight? I'll just observe the color of the precipitate. No, all of them are precipitates. So this is pale yellow. This is yellow, or like, oh sorry, my bad. This is white, AgCl. My bad. This is white. This is pale yellow. And this one is dark yellow. So that's how I'm going to check it. Second way of checking it is that I'll be further treating it with ammonia. No, this is like a preliminary test. Then what do? You just treat it with ammonia. Okay. So when you do the further for confirmation, what do? You treat it further with ammonia. So when you treat it with ammonia, this gets dissolved. Your precipitates dissolve. The second case, when you try to do it, it gets partially dissolved, not completely. And when you treat the last one, AgI, does not dissolve. So that's how you can further do the distinguishing, and this is like further confirmation. Right? Does this make sense to you? Do you know that they pass ammonia on something? I went for practical and I was trying to take ammonia out in a test tube. Yeah, Bhumi. Taking ammonia in a test tube. Awesome. No one will dare to stand in front of you. So generally they ask you to plunge it with the help of that pipe. Now you just flush ammonia gas mostly. Perfect. All right. Acha, if I ask you another question. Okay. So my question is, if I have ethylene chloride versus ethylene dichloride, the question is ethylene chloride. How will you distinguish ethylene chloride versus ethylene dichloride? Nice. Now, first of all, the question is कि ma'am इनके names में क्या अंतर है? Of course, you would be asking me this. कि like distinguishing तो हम बाद में करेंगे. First, you tell me the name. Yeah. So the first one is geminal dichloride, and the second one is vicinal dichloride. Right. Now the question is, how will you still distinguish the two? Now still tell me. How will you distinguish between the two? Zinc dust. Okay, like how will that help? If you use a zinc dust?
Zinc dust will just bring back the complete reagent, right? Does it work here?
No. It is acting like basically zinc is a metal. So like it is getting oxidized in case of phenol. When you use it on phenol, na? Tab zinc oxide आप use करते हो, so that zinc gets converted into ZnO and the phenol part gets converted into benzene, but it doesn't work here. So that's not the purpose. So here, how do you work?
Bromine test.
Bromine test. Yeah. इसका टेस्ट बड़ा सिंपल है, but it is again based on like the reactions. So I'll tell you the elimination. Kind of, not exactly though, but I'll tell you, yes. What do? You treat it with aqueous KOH. So how will you distinguish it? Using aqueous KOH. How? How will it help? Look at the first one, the geminal one, right? Can I say both the chlorines will be replaced? This is the function of aqueous KOH. It is giving you substitution reaction, right? So it is going to substitute your chlorine with OH. Now I know two OH on same carbon are not stable, so they will remove as water, and what I'll be getting is an aldehyde, right? But in the second case, what I'll be getting is a diol, right? So basically, this is going to give me all the tests which an aldehyde can. In biomolecules, you have seen so many tests, Tollens, Benedict's. कुछ भी कर लो, खेलते रहो इसके साथ. Whatever you want to do. 2,4-DNP, Fellings, whatever you want to do with it. And this will give Schiff's test. But the right-hand side wala will give none of these tests. Yes? Make sense? Yeah. This is how we can do the distinguishing. So it's not like most of the times it's not mandatory that you'll get a direct question. A direct question means the known reagents to do the distinguishing. For J level, you have to think that if and options are the best way to think, because sometimes you're not getting an answer. But if I'll give you an option, so you will try to see, okay, this reagent, will it react differently with my two reactants or not? And that's how you'll try to conclude an answer. Okay. For example, I'll give you another question. Okay. एक बड़ा simple सा question है, but yeah, let's see how will you do it. For example, though it's not related to this chapter, this is related to the next chapter, but anyway, that chapter is also coming in your examination. I have this alcohol versus this ether. So same molecular formula, different functional groups. How will you do the distinguishing? Sodium metal. All right. Very good, Priyanshu. I can use a sodium metal. Good. So with sodium metal, ethanol will produce hydrogen gas, whereas there is no such reaction with ether. Solubility in water, yes, ether is not soluble and alcohol is still soluble, thoda bahut. But when I say distinguishing test now, basically I want those kind of things which are visible with respect to like colors or some gas production, some precipitate formation. So this is a very clear observation. Iodine. Oh yes, this also is done with the help of iodoform test. Ethanol will give, whereas ether won't. And technically, Lucas reagent test also you can use, bilkul. But again, इस वाले केस में क्या प्रॉब्लम है ना भूमि कि प्राइमरी अल्कोहल्स के साथ, if you remember, ल्यूकस केस में टर्बिडिटी आता ही नहीं, बहुत ही प्रॉब्लम होती है, तो इसलिए it won't be effective. So effective नहीं होगा, but yes, it is a test. Okay, so Darson's reaction is Lucas 1 only. So yes. Up for idoform test, the structural requirement is, I think I've discussed in my regular classes, either this or methyl ketone. These are the major structural requirements, but doesn't mean that these are the only ones. Okay. The J advanced, we will be discussing more like deeper into it. That इसके अलावा भी और कौन-कौन से तरीके के substances हैं which can give you iodoform test. Same way Tollens reagent हमें देखने में ऐसा लगता है कि it's just for aldehyde. Yeah. But शायद तुम लोगों में से कुछ बच्चे भूल गए होंगे. Last year in alkynes also you have done Tollens reagent. Terminal alkynes भी Tollens देते हैं. Terminal alkynes भी phalanx देते हैं. They also give you phalanx test. They also give you terminal others. But यही दो नहीं है, ऐसे बहुत से और भी compounds हैं, which further gives you Tollens reagent test. We'll be doing it in advance. PCl5 reaction can say, but CH मतलब ether के अंदर भी ना depending on the reaction conditions CH2Cl आ जाता है. ठीक है, but mostly yes you can do, but उससे फिर proof कैसे करोगे? Compound बन गया धारा, तो वो compound से थोड़ी फर्क पड़ रहा था. Color change या कोई gas production या वो चीज चाहिए थी ना. ऐसे तो reactions हैं दोनों की different, but जो quick change ऐसा दे जिससे मुझे एकदम से समझ में आए. That's the point, right? Okay. So in the, like, whenever we'll have our next case, so at that time we'll have a further discussion about like more sorts of distinguishing tests कि अच्छा और किस तरीके के cases हम देख सकते हैं where we can distinguish the reaction. Yes, there. All right. So we'll be discussing the more things, like whenever we'll get a next class, we'll try to cover up alcohols, phenols. इसी तरीके से we'll make a scheme and we can see the different distinguishing cases where we can work on many reason-based questions, right? All right. Not for everyone. Okay. All right, so that's it for today's session. We'll meet in the next class and we'll be turning further. Bye-bye. Take care. Enjoy your time.
Thank you, ma'am. Bye, ma'am.
Bye-bye.